Hello everyone, welcome back to Math Specs. My name is Stephanie. Today is a very exciting section. We're going to be talking about solving multi-step equations, which was my favorite thing when I learned algebra. Today we're going to be doing some very basic and introductory examples just to kind of keep in line with the series, but hopefully in future videos we can do much more challenging examples. So let's get started with today's lesson. So we're just going to jump right in and use everything that we learned in the previous two sections that we learned using addition and subtraction to solve equations, as well as using multiplication and division to solve equations, because remember, they're all inverse operations. And here our approach, remember our goal whenever we're solving equations with variables is to isolate the variable. We want it to be all by itself on one side of the equal sign. And here, to undo addition, I think this is more specific to the problem. So we're going to go ahead and just look at the problem and fill this out as we go. So we have 4x plus 5 is equal to -2. Okay, so remember, we want the x by itself, and we have this plus 5 here, so this is actually where we're going to start. So to undo this addition of a positive 5 or that we're adding 5, we're going to subtract 5. So we're going to subtract 5 from both sides. So that's what we're going to do. So remember, we have to do it to both sides. These 5s will cancel. Then we can bring down the 4x, our equal sign, and -2 minus 5. We can take care of this, and this will be -7. Okay, now we have 4x is equal to -7, and 4 is being multiplied times x. So in order to undo this multiplication, we are going to divide. And we're going to divide by 4 to both sides. So let's go ahead and do that. We're going to divide 4 here, and we're going to divide 4 here. These 4s will cancel, and so we'll be able to bring down our variable. And -7/4, well, we can't reduce that any further. And if we can, we'll just leave it as an improper fraction, but we've solved for x. And you can continue to do this approach, but ideally you would already kind of be following these steps in your mind already. So you can write these down if it will help you kind of be able to track what you're doing at each step, because whatever method helps you, go ahead and do it. Okay, so let's go ahead and continue to the next example. Here we have 6x minus 15 is equal to 10. So I'm going to start here. I'm going to add 5 to both sides. Okay, then these 5s will cancel. I can bring down my 6x, my equal sign, and 10 plus 5 is going to give me 15. Now I have 6x is equal to 15. 6 is being multiplied, so I'm going to undo that by dividing by 6 to both sides. These 6 on the left-hand side will cancel. Can bring down my x, my equal sign, and my 15 divided by 6. I think I can reduce that. Can divide it by 5/2, I think. Yes, 5/2. It's going to be 5/2 because I divide this top by 3 and this top by 3. Okay. So that is our answer. Let's go ahead and continue to the next example. Here we have 2y minus 2 is equal to -6. So in order to get y by itself, I am going to start here. I have -2 or -2, so I'm going to add 2 to both sides. These 2 will cancel, and I can bring down my 2y, my variable, my equal sign, and -6 plus 2 is going to give me -4. Now I have 2y is equal to -4. So this is multiplication, so I'm going to undo it with division, and I'm going to divide by 2. So now I'm going to cancel those 2's. I can bring down my variable, my equal sign, and what is -4 divided by +2? That's going to be -2. Okay, Pretty easy, pretty simple. Let's go ahead and continue to our next example. Here we have 3g minus 2 is equal to -8, and we want to solve for g. We want g all by itself. So here I have -2. So instead of subtracting, I'm going to add 2 to both sides. These 2's will cancel, okay? And then I can bring down 3g, my equal sign. -8 plus 2 is going to give me -6. Now I have 3g is equal to -6, and 3 is being multiplied by g, and I want g by itself. So I'm going to actually divide by 3 to undo this multiplication. And what I do to one side, I have to do to the other side, okay? These 3's will cancel, and I can bring down my g, my equal sign. -6 divided by 3 is what I have on the right-hand side. This is going to be -2. Okay, so that is my answer for this example. Let's go ahead and continue. Here I have 8n minus 3n minus 4 is equal to 21. So as you notice here, we have like terms. Okay, and what are we going to do with these like terms? We're going to actually combine them. So I have 8n minus 3n. This is going to be 5n. And I can bring everything else down. And now we can solve for n. Okay, so I have 5n minus 4 is equal to 21. And here I have minus 4. So instead of subtracting, I'm going to add. So I can move the 4 to the other side. These 4's on the left-hand side will cancel. Then I can bring down my 5n, which is what I have left over, my equal sign. And 21 plus 4 is going to give me 25. Now I have 5n is equal to 25. And 5 is being multiplied times n, so I'm going to divide by 5 on both sides. The 5's here will cancel. And I'll have left over n, which is what we wanted, and 25 divided by 5, and they're both positive, so my answer is going to be +5. Exciting, fun. Okay, so let's continue to the next example. Here we have 3 times k minus 4 is equal to 6. So we have to use, what do we have to use here? We have to use the distributive property. Yes, we have to distribute the 3. So we're going to distribute this 3 into these parentheses. So we have 3 times k. This will give me 3k. 3 times -4. That's a positive times a negative. So it's going to be a negative. It's going to be -12. Then I can bring down my equal sign and whatever I have on the right-hand side, which is just 6. So I have 3k minus 12 is equal to 6, and I want k by itself. I want to solve for k, so I'm going to start here. Minus 12 or I'm going to subtract. No, I'm actually going to add because I have subtraction. So I'm going to add 12 to both sides. These will cancel, and I can bring down 3k is equal to, that's going to be 18. 6 plus 12 is 18. Then I have 3k is equal to 18, and 3 is being multiplied times that k. So I'm going to divide by 3 to get rid of, to undo that multiplication. The 3's will cancel, and I can bring down my variable k, and 18 divided by 3 on the right-hand side will give me 6. And that is my answer for this example. And finally, I'm going to clear our drawings here. We have 1/4 times y plus 10 is equal to 5. So again, what are we going to use here to begin with? We could also actually, in this example, I'm going to show you how we could not use the distributive property. Okay, because that's also another method that you could use. So if you have 1/4 here, you don't have to distribute it in like we did in the last example. What you can do is instead just get rid of it. So what we do is we're going to multiply by the reciprocal on both sides. Okay, so because what I'm seeing here is that I have this fraction, and if I distribute this, I'm going to have 1/4 y plus 10 over 4. And I don't want that. I just want to get rid of this fraction. So I'm not going to use the distributive property. I'm actually just going to get rid of it by using, by multiplying by the reciprocal. So what I'm going to do is I'm going to multiply 4 over 1 on this side and 4 over 1 on this side. Okay, so then the 4's here will cancel and the 1's will cancel here. And now I have this, okay? So now this fraction on the left-hand side is gone because what I'm left with is y plus 10. And on the right-hand side, I have 5 times 4 over 1, and that's just 20. Okay, because 1 times 1 on the denominator is just 1. So now I have y plus 10 is equal to 20, and I can solve for y. And I have, I'm adding 10, so instead of adding 10, I'm going to subtract 10. So I'm going to do that to both sides. These 10s will cancel, and then I can bring down my variable by itself. And 20 minus 10 is just 10, because this 20 is positive, and so this is my answer. But what if you wanted to actually distribute? What if that was what you did, or maybe you committed already and you want to see what that was like? So let's distribute. So we would have 1/4 times y plus 10 over 4, and that would be equal to 5. Now we would have to subtract this 10 over 4 from both sides. Okay, and then this would cancel. Then I would be left with 1/4 y is equal to 5 minus 10 over 4. Okay, so then what I can do here is have my common denominators for the right-hand side. So then that would be 20 over 4 minus 10 over 4, and I would get 10 over 4. And then I would multiply by 4 over 1. So I'm actually going to go up here. I'm actually going to move up over here to this other side. I'm going to go up there. So I have 1/4 y is equal to 10 over 4. So now I'm going to get rid of this 1/4 by multiplying by the reciprocal. So 4 over 1 on this side and 4 over 1 on this side. And the 4's will cancel on the left-hand side. And I'm left with y. And then 10, well, I can just cancel this 4 and this 4. And my answer is y is equal to 10. So there you go. Another way that you could do it if you really wanted to use the distributive property, and if you were fearless of those fractions, you could do that. So let's go ahead and continue. So that is the end of today's presentation. Thank you so much for your time and attention. Today we learned how to solve multi-step equations with an emphasis on inverse operations, combining like terms, using the distributive property, and multiplying by the reciprocal to solve equations. We've done a lot today. Thank you so much, and we will see each other in the next video.